Now, it should have, I don't know why in version 21 it doesn't do this, but have you seen in your output where it has the commands? Yeah. Talk about those commands. In this case, that's what told the computer to do a two-way ANOVA. And here are the options that I selected. I told it to make a plot. I mean, it's all pretty straightforward when you read the, it's not here for some. Here's the descriptive statistics. Okay. So we can kind of get an idea of what the data looks like. There's 4 majors. We can tell there's 2 factors, right? 2 independent variables. One has 4 levels. One has 2 levels. Okay. Here's the descriptive statistics. We can look at that. Obviously, there's not much to annotate there, right? I mean, you're just stating, okay, this is where the descriptive statistics are. But right here is where you could talk about how many levels in each factor there are. Okay? That's useful information. Then I would say, this is where I find if we've met the assumption for homogeneity of variance. Okay? Highlight this. What value is this? That's the p-value. Remember, if p is less than alpha, you reject the null. In this case, we don't want them to be different. We want them to be the same. Remember, homogeneity means same. We want the variances to be the same. So we want to fail to reject the null. So that needs to be greater than 0.05, which it is. It's 0.248. It's the same as the one way. Same as we wanted this p-value to be greater than alpha. So I would circle this or highlight this and say this is the significance, p, and it's greater than alpha, which is 0.05. Therefore, we've met the assumption for homogeneity for variance. Now, we have we could put over here somewhere, here's the results of the omnibus test, or the two-way ANOVA. The sum of squares are here. We're ignoring this. Maybe highlight these over here. This is what's important out of this table, right? That's significant. So this was less than alpha. This was less than alpha. This was less than alpha. This wasn't significant. What's that? Gender. Okay? There was no difference in gender. There was a difference in major. Oh, we're ignoring this up here too. There was a difference in major. There was no difference in gender. There was an interaction effect, okay, between major and gender. And here are the effect sizes. They're using eta squared. We have a formula for omega squared. There's several ways to find effect size. But this is, so you could say, okay, and here are the effect sizes. Let's go ahead and go down. Remember, it was statistically significant for an interactive effect. So we need to consult the plot. What is this plot saying?
They intersect, so.
Who wrote that down? Yeah. So, what we're saying is how these, what's the dependent variable in this? Anybody remember? Score, okay, whatever, let's look at see what score was. Oh, exam score. Okay. So the exam score for for these particular majors, did not have the same effect across the levels for gender, or across males and females, for all four. Here was the effect for vocational education. It flipped for physical education. Flipped again here. Is that a flip? No, almost flipped. Here for English. And then had this opposite effect as over vocational education than it did for mathematics. So you're just, yeah, you're talking about, this is illustrating what type of interaction there is. Because they intersected, it was a disorderal interaction. Meaning, this is where I get tongue-tied. Bear with me. The exam scores across the levels for major was not the same for males and females. Right? Does that make sense? Look, they flipped. If there was no interaction, what would this graph look like? Parallel. Or, as, you know, accounting for some sampling fluctuation. So basically parallel. Okay? If they were parallel, then that means they're having the same effect for males and females. If they're not parallel, but they don't intersect, yeah, there's a different effect, but it's not disordinal, it's ordinal, meaning the direction is the same, right? Just in varying amounts. If they're disordinal, you're having an opposite effect in some case, over some levels than others. That makes sense?
Can you do that one more time? With the plot there.
Yeah. Look right here. The exam scores for people who majored in vocational education. I don't know if this, these are females. For females scored lower than males. But for mathematics, females scored higher than males. So there was the same effect of major was not across all levels of gender. Does that make sense?
Yeah.
The exam scores for gender were not the same across all majors. That's what interaction is. If there's interaction, then now you need to do a test for simple effects, which we'll talk about more next week. Yes?
Okay, I'm sorry, I'm gonna backtrack a little bit. I'm looking for the degrees of freedom. If you don't have the numbers of participants, or you don't have the total number of participants, you can't calculate the degrees of freedom within, correct? Or can you?
Within. So for within it was n minus, so yeah, you need n, capital N.
So in the homework assignment number 5, you don't give us the total number of participants. Sorry to jump ahead, but I was just kind of looking at that and got confused.
I need to see that. Homework number 5.
Yeah.
I'll email you guys about that. Okay. Any other questions about how to do a 2A ANOVA using SPSS?